Hello students, welcome you all. In my today's lecture of this alkyl halide series, I will discuss the E1 reactions. In my previous lectures, I told you E2 reactions, SN1, SN2, SN1 dash, SN2 dash, SNI reactions. Now let's explain this E1 reaction. E1 reaction, this is elimination reaction, and elimination 1 stands for unimolecular. So elimination unimolecular reaction, or we can write unimolecular elimination reaction. So what are the main features of this reaction? So main features, so one of this feature that this like that of this SN1 reaction. So SN1 reaction, these are the two-step reaction. In the same way, this is also two-step reaction. So it is two-step reaction which occur with the formation of one transition state, which occur with one intermediate. And intermediate is here carbocation. Okay, so here the first step is a slow step, and second step is the fast step. In first step, carbocation intermediate is formed, and in second step, from carbocation we get the alkene. So first step is slow, where carbocation is formed, and second step is fast, where alkene is formed from carbocation. Okay, so if we see the energy profile diagram for this E1 reaction, then energy profile diagram, it would be, suppose this is the reactant, and this reactant, this is our first step, this is second step, and finally this product is formed. So this is our transition state 1, and here this is transition state 2 which is formed, and this is our intermediate. So if you see this first step, it requires the activation energy for this first step is higher, whereas activation energy for this second step is lower. So this first step is slow step, and the second step is the fast step. Next, such reaction, it follows the first order kinetics, as it is a unimolecular reaction, so it follows the first order kinetics. Means if the rate of reaction, it depends only upon the concentration of substrate. Here the substrate, it will be alkyl halide, or it may be any alcohol. We may take also the alcohol as a substrate. Whereas if we see this E2 reaction, then E2 reaction was the second order, and rate of reaction that depends upon the concentration of substrate as well as the concentration of this strong base. So here no strong base is required. Okay, so no requirement of strong base. No requirement of strong base. And this reaction, it may occur in presence of solvent which act as a weak base. So the reaction take place in presence of presence of solvent as a weak base. So solvent may be, here we may take the water as a solvent, it acts as a weak base, or we may take methanol or ethanol. So such solvent may be used in this reaction. And next thing, there is no requirement of stereochemistry in the substrate molecule. So what we have seen in E2 reaction, reaction, the alkyl halide, the substrate molecule, in substrate molecule, the leaving group and the beta hydrogen atom, that should be anti-periplanar to each other or anti to each other. Here there is no requirement of stereochemistry in the substrate molecule. Okay, so no requirement of stereochemistry in substrate molecule. So either the substrate may be, in substrate the leaving group and the beta hydrogen atom may be anti to each other, or it may be same to each other. Now, the order of this reactivity of alkyl halide, as what I have told you, this carbocation is formed as an intermediate in this. So the order of reactivity of substrate molecule is tertiary, more reactive, then secondary, then primary. So primary usually doesn't give this E1 reaction. So tertiary, because this tertiary alkyl halide if we take, then it will give the tertiary carbocation. That's why the tertiary alkyl halide reactivity is more than the secondary, like this. Okay, now next thing, here suppose this is carbocation, suppose in carbocation if there is a chance of rearrangement, then the carbocation may undergo rearrangement to give the more stable carbocation. Okay, so the carbocation may undergo rearrangement to give more stable carbocation. Okay, so this is some of the features for this E1 reaction. Okay, now let's see the example of this E1 reaction. And in E1 reaction, one thing, some side product may be formed. Okay, some side product which may be formed via this SN1 reaction also. Okay, means some parallel products may be formed by the SN1 mechanism. So some parallel or this minor product may get formed via SN1 mechanism. Okay, so these are some features. Now let's take one of the examples. Suppose if we have any alkyl halide, so if this is our alkyl halide, and this in presence of water, and if we heat it, because heating is one of the essential condition in case of elimination reaction. So if we heat it, then what product that would be formed? The product is our so this alkene would be formed. Here one of this alkene is formed, and with this alkene we may get this either this, suppose this is the leaving group. Okay, this bromide ion will leave out, and So this is the main product which is formed. Now some side product may be formed via SN1 reaction. So this is our even product. This is our even product, and some side product may get formed via SN1 mechanism. And we know that in SN1 reaction the inversion product is formed as well as the retention product is formed, and inversion product predominates over the retention product. So here if we see, then one of the product which is formed is the retention product, and another product that will be the inversion product. So this product is formed via this SN1 mechanism. This is SN1 mechanism, but they are very minor product. They are very minor product. So this is our retention product, and this is the inversion. Okay, this is the inversion product. But inversion product predominates. Inversion product in SN1 reaction, inversion product predominates over the SN over the retention product. Okay, so this is one of the example. Now let's take some more example. Now in another example, suppose if we have, this is the example. Now this in presence of water as a solvent, and if we heat it, then the product that we will get, and this would be the product. This would be the main product, and another product we may get another product also. This will be this major product here. This is major product, or this is most substituted product, tetra substituted product, and this is our minor product. Plus we have, suppose, bromide ion and H3O plus, that would be removed. So this is the jet safe product, is the major product here. And this is the non-jet safe product. So if we see the mechanism for this, then first of all, in a slow step, the formation of this tertiary carbocation will take place. Bromide ion being the leaving group, it will leave out. Okay. So bromide ion leave out, and in second step, suppose if we have this hydrogen over here, then H2O molecule will act as a base, and it will take out this hydrogen proton, and the double bond would be formed over here. So we will get this product. Or otherwise here also one of the hydrogen atom is there. It may also take this proton, and the double bond may form over here. So but that is the less substituted product. That's why it would be the minor product. So this is minor, and this would be the major product. Okay, now let's take another example where I will show the rearrangement to get the more stable carbocation. Suppose if I have okay, suppose if I have this one, and here suppose if I have yes. So in this case, if you will see, in presence of water and heating, so what we will get the product. So the first step, as I told, it will be slow step with the formation of this secondary carbocation. So bromide ion will leave out, and here positive charge will come. In second step is the first step. So here this secondary carbocation is formed. And in second step, in next step, okay, in next step first the rearrangement of this will takes place and methyl shift will occur. So methyl shift to get the more stable tertiary carbocation. See, so here this is the tertiary carbocation, and now water as a base. Now water as a base, it can abstract one of the hydrogen proton from here, and the positive charge will be neutralized and we will get the alkene. So this is our product. Okay. This is the main product. Otherwise, the hydrogen or proton that can be abstracted from here to get the minor product. So we may get one of the minor product also. So this minor product may be found here. So this is major jet safe product and this is the minor one. Okay. So these are few examples for this even reaction. Thank you. In my next lecture, I will explain the even CB reaction. Thank you.